I think some big things are about to happen here. What I'd like to do today is kind of talk about the future, the near future. And it's in this context. It's in the context of this little tiny dot of Earth in the top left-hand corner. I made a conscious decision when I was creating this slide deck, not necessarily to show the blue marble image. If you look over my shoulder, the flag that I have here, I've had this flag since, I don't know, probably 8-10 years. It is the blue marble image. So this event, it's not a gimmick. It's something that I think that that we believe in, that there is something profound happening and has been happening since December 7th, 1972. So I want to just kind of pause for a second and just think about this little blue dot in the left-hand corner and this target of this larger immense moon that's available to us. And I want you to think about all the things that are happening from the ground on the Earth to the moon. It really is quite astounding. In my nearly 20-year career in the space field, and I usually work on pretty wackadoo out there ideas. So I'm very comfortable in kind of frontier technology, frontier development. But in my 20 years of doing this, we've evolved from having about 400, slightly less, 350 satellites at all. In the whole cis-lunar ionosphere, there were only about 350 to 400 satellites. And some of those were dead and inactive nearly 20 years ago. Now, fast forward to where we are today, we're just shy of 4,000 satellites, a tenfold increase in a pretty short amount of time. And that by itself would be astounding if that was the whole story, if we just stopped right there. But that's not the whole story. The rest of the story, the unfolding story, is that within the next 10 years, we're very likely to have 40,000 satellites, another tenfold increase. But there's strong arguments because of the mega constellations that are designed and in development. There are strong arguments that we could have 90 to 120,000 satellites, 90 to 120,000 satellites. And that stat comes straight from the Satellite Industry Association. So this space that we're showing between the Earth and the moon, what we refer to as a cis-lunar ionosphere, there's a lot currently happening, and there's a lot more going to happen. So when Tim and I were bouncing around the idea of this blue marble week concept, we put some rules into it. We put some boundaries around it. And one of the things that two of the things that we really wanted to focus on was current technology, what I refer to as sometimes as purchase orderable technology. When I first started working in the space field, I worked on chasing Bigfoot. And I say that sarcastically, but it was the development of the Earth's space elevator. And that meant we needed to have carbon nanotubes in order to have the strength requirements for the string. And it felt like chasing Bigfoot. I would literally go around the country and around the world when someone spotted a new technology that would be transformative. And I did that for a long time, and we had a pretty good sized team working on it. But in the end, nearly 20 years later, no one in the world yet has a material strong enough to build the Earth elevator. So when LiftPort switched gears to focus on the lunar elevator, I made the conscious decision that we wanted to work with purchase orderable technology. And so I talked that over with Tim. And what we wanted to showcase at Blue Marble Week was aspirational for sure, but near term aspirational. And what we mean by that is technology that is grounded in developed and developing science. It takes place between the Earth and the moon. We're not extending out beyond Mars. We're not extending out to asteroids. We're also looking at a very specific time frame. What is happening immediately? 2020, 2021, 2022, 2023, really focused on the here and the now. And then also think about soon. And what does soon mean? For us, it's 2035. So everything that we're talking about is really focused within those two boundary points, from the ground to the moon and from 2020 to 2035. But we're also trying to understand, how does this impact the world, right? There are going to be a whole lot of new astronauts, but how does that impact the people down here on the ground? Tim talked about his kids and they're wanting to go to space, and I fully support that. And you're going to meet some interesting folks later today that have some aspirations. But what about the 7.7 billion people living down here on the ground? How does Blue Marble Week impact them? And so one of the other elements of this Blue Marble Week was to really focus on the economy, on infrastructure, not just on STEM. World Space Week does a really great job at focusing on STEM, but we want to look at the impacts of STEM. What does studying science, technology, engineering, and math mean to us down here on the ground? And that always comes back to jobs and economy and gross domestic product and quality of life. That comes back to having hospitals with better technology, cars and airplanes with better technology. It comes back to your Amazon Prime product arriving on time when you think it's going to, and that is tracked from the moment you hit your order button through the digital payment system, through the warehousing process, to the GPS tracking your product from the moment it leaves the warehouse to the moment it arrives at your doorstep. That world, the world that we're in right now, where we're sharing video screens and we got folks from around the country and around the world, this is the world that we're living in, and it's a product of that STEM technology. So when we start talking about Blue Marble Week, we want to talk about how this relates to us down here on the ground. We've got a grand architecture I'll describe here in a bit. But as we unfold the next, from December 7th today to December next year, we've got a whole series of very focused conversations, very focused events. And they're all wrapped around this concept of getting us from here to there. So I hope you'll join us on that journey. The last thing I'm going to say about Blue Marble Week is that we hope that it is inspiring. In the same way that Yuri's Night is a global space party, and the way that World Space Week is a global education program, we hope that Blue Marble fits right in the middle of that. It should be a celebration, but it should be a celebration with an exploration of what's coming next. So let's talk about where we are and where we're going. And I want to really, really stress that this is an apolitical event. I think Tim said it best what it is, saying it is aggressively and fiercely apolitical. There are folks that are speaking later today and tomorrow and Wednesday that some of them have some very important roles and responsibilities, and we don't want to get dragged into the middle of an argument. So we're going to be ignoring questions about politics, but within that, we live in the world, we live in the United States, and there's a current policy out there, maybe subject to change, from the National Space Council. And it is, in a way, it is a starting point for this grand architecture. Important caveat, I've been talking about the grand architecture for almost 15 years. So all I saw when I read this document was it reinforced the plan I'd already been embarked upon. So what is this thing? There's 5 parts to it: commercialization of low Earth orbit, returning to the moon, extending to Mars, science and technology beyond those borders, and workforce as infrastructure. It's got some great language. It's not a very long document. It's only about 20 some pages. I really strongly encourage folks to take a look at that. It is the binding document currently. I think it will, at the very least, pieces of it will stay in place. But I think it's a pretty good plan. And what does it mean, right? We are going to be focusing really on the first 2 elements: commercialization of LEO, and then going on to the moon. So I know this is super boring. I apologize for that. We'll get into some more interesting stuff in a second, but I want to actually dive into the words of this document because they matter. They matter. There is a very, very strong emphasis on private sector revenue generation. It's actually quite amazing. In my career of doing this, I've never really seen a document this, I will say, brazen about focusing on commercialization. If you see behind me, there's a ton of books. Many of them are old school science fiction. That's how I got involved in space in the first place. And there's all of those books talk about private sector pursuit of profits. This document refers to regulatory barriers and how do we take them down. I really like the idea that companies can invest and reap a reward. They can invent and earn the results of their intellectual property. So the document really focuses on building a pipeline of research and development in low Earth orbit. But it's also talking in a different paragraph, it talks about what we need to do down here on the ground. So as we build these commercial platforms, we will eventually be able to shift from Earth orbit and out into the moon. We're going to create communications, propellant depots, astronaut training, and ultimately health research. That kind of thing we've been doing for a while. The International Space Station's been operational for 20 years. But this language really emphasizes the kind of co-development with the commercial sector. And that's an important shift. And very near and dear to my heart are the idea of having fuel on orbit, whether that's propellant depots or space tugs or gas cans that come flying to you. We're going to develop longer lasting capabilities, life support, power generation, transmission, storage, surface transportation, and ultimately resource utilization. There's a lot of science fiction out there that talks about how we're going to create these modules that are self-replicating, that can build stuff out of lunar regolith. There is a big step between here and there. And there are a lot of folks working on that technology, but it is still very, 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 very challenging, and we're not there yet. So the work has to continue, and I feel confident that over the next few years that will happen, but we will get results by doing this work. We will get results that we can use down here on the ground by doing this work. The act of having long sustainable life support off-world will have impacts down here on the ground. This long-term presence in low Earth orbit, that's I think what we're all striving for. That's what I think. I assume everybody on this call probably wants long-term presence in low Earth orbit. I gave a lecture to ISU, International Space University, about 3 weeks ago, and I asked them, how many people do you think are going to be in orbit as astronauts, whether private or government? How many people are going to be astronauts within the next 5 years, the next 10 years, the next 15 years? It's taken nearly 60 years to get a little over 600, 650 astronauts. That's great. I mean, that's a pretty remarkable accomplishment for our global civilization. But Virgin Orbit has 400 to 600, the number's a little bit fuzzy, between 400 and 600 paying clients. I kind of tend to shy away from the idea of tourists, but they have paying clients that are going to take suborbital trips up into the sky for a little while, just a few minutes of weightlessness, and then come back down. Do they qualify as astronauts? Yeah, I think they probably do. Is that the first step towards point-to-point suborbital? Yeah, I think it probably is. The idea that you can go from one city to another city in another continent in 45 to 75 minutes instead of a 15-hour, 20-hour flight. I mean, I think that's revolutionary, and I don't use that word lightly. So what we have learned by going to space is only the tiniest fraction of what we're about to learn. It is conceivable that we could go from 600 to 6,000 astronauts in the next 5, 10, 15 years. And how is that? We're going to talk about that a little bit more in the presentation today. But imagine a world where we have already seen satellites go from 400 to 4,000 in 20 years, and it's going from 4,000 to 100,000 in 10 more years. So that exponential curve is boggling. So why not be able to apply that to humans going to space? I'll tell you what the breakthrough is on that in just a bit. focusing on the International Space Station, we know it has a lifespan. We don't know exactly when, whether that's 2024, 2028, or some extension beyond that. But we, the United States, will not build another ISS. I really don't think that's very likely. I think it's unlikely that our international partners will also not build something like the ISS. We know that Russia is going to carve their modules off and create something independent. We know that China is building something independent with some European partners. So over the course of the next few days, we are going to be talking about space stations quite a bit, mostly on Wednesday. But whatever happens, we're not going to duplicate this asset. So when that chapter is closed, we need to make sure that we've got something else. And the something else is very likely commercially owned and operated space stations, which I'm 53 years old. That is literally the stuff of my high school dreams. So that it took a little while to get us here, I don't care. I'm patient. We're going to do amazing things with these space stations. But it's also important to note that the United States government, while being a major actor, is not the only actor, and that the world that we were very comfortable in with a USA versus USSR, where there were two superpowers with an interest in developing global influence by their space program, we're not there anymore. That's not how this is. There are dozens of space agencies now. They all have their own agenda. For the most part, they are observation and communications agendas, but not all of them. Not all of them. There are wild cards like the United Arab Emirates that has strong ambitions and a strong program towards going to the moon and most especially Mars. So before, it used to be two clients, the Soviets and the Americans, two budgets, and one singular mission, the moon. Now there are arguably hundreds, if not thousands, of individual clients with arguably hundreds, if not thousands, of individual missions. Many of those missions are complementary. Many of them are competitive. It would not be hyperbole to say there were north of 100 budgets with north of 100 individual tasks or goals. So the United States government will be a component of a much wider, broader, richer cis-lunar econosphere and cis-lunar ecosystem. I'm almost done with the slide chart, the eye chart here. So just bear with me here. What we're doing preps us for Mars. That's really what this document that came out of the White House a couple months ago is really trying to say. Our event here this week is really not focused on Mars, but it's important to note that what happens out on the moon is a precursor to going to Mars. The guy on the left here, now retired Lieutenant General Stephen Quast, he'll be speaking later in the day. And one of the things he said to me was, this is maybe the most important conversation in our nation's history. And at first I thought that was hyperbole. And then after our phone call, I really just pondered that for a moment. And I think it might be accurate that the steps that we take as a nation, as a species, as we move permanently off world, How we do that matters. How we do that, I think, is very significant. And then the guy on the right, Dr. Joel Moser, is the chief scientist of U.S. Space Force. Surprise announcement, I am hoping that he joins us on Wednesday as our closing speaker. He has given us a tentative thumbs up that he'll be here. So barring a very busy man's very busy schedule, we hope that he will be joining us. So it's really interesting that these two folks are kind of the bookends for our keynotes on Monday and Wednesday. Between them, their insight is pretty powerful about the very near term future. And given the context of their roles, formerly in the government and currently in the government, they have some very interesting insight into the near future. Look, we know that the moon is very close, but it's also, relatively easy compared to going to Mars. It's not an 8-month trip, it's a couple-day trip, which the Chinese found out very recently. A couple days ago, they were the only nation ever to have 2 simultaneous assets on the surface of the moon. America's had stuff circling the moon for a really long time. Israel made an attempted landing last year. They crash landed. India made an attempted landing last year. They also crash landed. Between them, that was $250 million worth of crater and rubble, but remarkable that it happened at all. And so we will be talking to one of the architects of that Israeli mission on Wednesday. But reducing risk, right? Going out to the moon is shockingly hard. And the stuff that happens in between here and the moon is shockingly difficult. And we're going to have to grow the number of habitants. I mean, just think about that. Like this is kind of a benign sentence, but there's only been 12 people walking on the surface of the moon ever. And depending on how budgets lay out in the current and next sessions of Congress, we could see that number of inhabitants grow very quickly. And I think the phrase, the number of inhabitants is very benign, right? It doesn't really, like if I wrote this, if I was the person who was writing this document in Washington, D.C., I couldn't help but slip in an exclamation point at the end of this sentence, because I want the number of astronauts on the moon to increase, right? So that's the kind of stuff that's happening. While the language might be dull, the results are pretty darn exciting. Running around, doing surface mobility, getting astronauts and cargo, very importantly, cargo to and from the moon. On Wednesday, we'll be having a speaker from NASA come in and specifically talk about Gateway and Artemis. And it's also super important to talk about this interoperability, right? That commercial and national and international partners all must work together with some sort of standards organization. And so NASA has been focusing on the communication interoperability standards, but there's a lot of standards that need to be developed. The International Space Station was a really strong example of how we could do that with 15 partner nations. But as we move out to multiple space stations, and we've got Tom Murata from the FAA going to be talking about space stations on Friday. As we start talking about the kinds and the number of space stations out there, we're going to have to get really, really good at interoperability and working with commercial and international standards. This sentence, this line at the very end, nuclear power generators and pressurized rovers, that means long-term energy and long-term capacity. It's not just about flags and footprints anymore. It's about going there with resilience. It's going there with determination, and it's going there to stay more than just a few hours or a few days. When you have this kind of energy capacity, it changes everything about what you do with your flags and footprints. You have opportunities with that much energy that you didn't have before. So that this language is a part of a federal document. Within 2 days of this document being released, the National Renewable Energy Lab issued calls for proposal for power generation for the moon. So as this document was crafted and released, it gave political cover to other organizations and other energy, the Department of Energy. It gave them political cover to do the kinds of things they wanted to do, but didn't have political permission to do. So that's a pretty big deal. And as the next year and 5 years and 10 years unfold, I think you're going to see more and more conversations about power and energy. We want to use the moon as a laboratory, as a stepping stone for going to Mars. Now, Mars is not my mission. That's not my personal interest and dedication. And that's not the focus of our event here this week. But it should always be in the background as kind of a necessary first step. The moon is a necessary first step. I think we all know that there's a whole lot more water on the moon than we ever imagined. It seems like every couple months we find that there's larger and larger ice deposits. We're now finding it on the equator, which we originally didn't expect. But just because it's there doesn't mean we can just drill like we do in the Texas Panhandle, Oklahoma Panhandle, and all of a sudden water's going to start gushing out. So I think the folks on this call probably already know that, but there's a very big disconnect with what the world and the community know about water on the moon. I find that very surprising sometimes when I have these conversations with folks, but there is a big disconnect with what people know. So I think it's important to us in our community to really clarify that this water ice on the moon is measured in parts per billion. You have to move a whole lot of regolith in order to sift out the good stuff. And we don't have anywhere near the technical capacity today to just move that volume of real estate. So even if we had all of the extractive processes and technologies, just the, I will say, earth moving, but it's really Luna moving equipment is a whole nother problem that's really been underappreciated. So first you have to move the dirt, regolith, and then you have to figure out how to extract and process this. But another step that is also necessary is the legal framework for staking a claim. Earlier in the summer, NASA released the Artemis Accords. I think those were a pretty brilliant document. Several nations, I think it's 8 nations, have now signed on to that document. It is being treated as a treaty, although it does not have the force of a treaty in the normal sense. Space law is not my necessary field, so don't quote me on that, but I believe that's true. But as these Artemis Accords are propagated out into the world, going back a moment ago about the international partnerships and interoperability, that's the kind of stuff that we're going to need if we're going to go to the moon in a significant way. So the idea of just living off the land, again, this would be another sentence that I would have wanted to write an exclamation point on if I was the author of this document. Living off the land on the moon is really, really difficult. Honestly, it's a bridge too far. We're not able to do that now. We probably won't be able to do that for the next 15 years. So it's interesting it's in this document, but it's not immediately achievable. This idea about ensuring a presence of strategic importance. I believe that General Quas is going to talk about that quite a bit today, so I'm going to skip through that. But it is really important to note that there are political decisions based on strategic positioning in the cis-lunar environment. Everything from low Earth orbit, geosynchronous orbit, all the way out to L points and ultimately the moon. They have value, and that value is becoming recognized. Finally, I'm just going to say it. It's about damn time that we send a woman to the moon, and I'm just going to leave it like that. We'll have precursors of robots, and there's a lot of precursor robots heading that direction. But soon, whether it's the arguable date of 2024 or 2028 or probably somewhere in between, we're gonna have some more boot prints, but it's not necessarily about political statements this time. It's more about achieving a goal that will have longevity. This last line about a secure and stable regime is pretty important. I believe, again, that Lieutenant General Quas is going to talk quite a bit about that. There is going to be a rule of law that governs operations in cis-lunar space. I'm curious to see ultimately how that plays out. And then finally, that's the end of those super boring slides, but I felt like it was really important to showcase what the current doctrine is and why it's important and how I think ultimately it's going to unfold. There is a role of government in all this. I think that's pretty obvious. There are current programs and there are potential future programs. I would say that that's one of the main reasons that the Blue Marble Week is hosting this set of events this week. And then more importantly, over the course of the next year, we'll be coming back over and over and over again to kind of current programs and potential programs. We know that we wouldn't be in space at all were it not for the pioneering efforts at NASA, and credit where it's due, in the Soviet Union. So how things have changed over 50 years is pretty startling and pretty remarkable, but there will absolutely certainly be a component of government in all of this. So how are we going to measure this? How is this ultimately going to be evaluated? Whenever we talk about space, we almost exclusively talk about hardware. It's the new cool sexy stuff, right? It's the thing that gets people's attention, because seriously, who doesn't want to watch a rocket launch and then miraculously, to me, it's still boggling to me, watching a rocket land. Of course, people want to talk about the hardware. It's fun, it's exciting, it's interesting, it's not easy. But that's not the whole story. So over the next couple days, we're going to be talking a lot about hardware, but we're going to talk about it from a different perspective. We're going to talk about it from the workforce perspective. How do you land a job in this field? What do you have to know? What kind of capabilities? We're going to look at it from the perspective of how does R&D go from big ideas like space development and satellites and space stations? How does that translate down here on the ground to value down here on the ground? So we're gonna. This isn't a showcase of cool new rockets. It's also not a showcase of, as much as I admire Blue Origin and Jeff Bezos's vision for that company, it's not about showing herds of elk on orbit in this park-like setting of a 1 million person O'Neill cylinder. Now, I like that vision. I definitely want to see humanity get to that point, but this is hardware grounded in the facts of the next 15 years, the things that we know or almost have at our fingertips. It's focused on from the ground to the moon, so it's going to leave out hardware, inspiring hardware like SpaceX's and Elon Musk's vision for Martian settlement. So the hardware that we're going to be talking about is space tugs. It's on-orbit transportation. It's developing materials in space for manufacturing. So this is a very different kind of space conference, if you will, because we're not talking about the normal stuff that we talk about in space conferences. The rockets are cool, but they're not the whole story. And it's important to start breaking away from that. We're going to talk about business. We're going to talk about the economics of finance and its role within this in this field. It takes a lot of money to do this stuff. It is not cheap. Fortunately, recently there has become a new amount of money that was not available 5 years ago or 10 years ago, or certainly 20 years ago. Capital for this field is available in ways that it has never been before. And why? Why is that capital available? It's because there's a return on investment. There are tangible results, and in Silicon Valley parlance, there are exits that people can point to and say, if money goes in on this side, it's going to come out on that side, and I'm going to make some along the way. So that's really important. What does the money of space look like? A third metric that is really important is outreach, storytelling. Who do we talk to? How do we tell that story? What is that story that we're telling? I would say that is vitally important. I would say it is probably the most underappreciated aspect of this whole space adventure that we're on. We're going to talk to a student this afternoon that's representative of that outreach effort. Julia Thompson is going to talk about her own experience, but she's also going to talk about the hundreds and hundreds of space programs in academia. It's really quite boggling how robust that community is. So outreach is not just telling stories in press releases and reading something in space news. It's also museums and movies and education outlets like universities and college and high school programs. That piece ensures that we have a future workforce. And so Shelley Brunswick at the Space Foundation is going to talk especially about that. And then finally, an element that we have mostly ignored in our planning for this event intentionally is the global framework, laws, policies. But what we did, how we addressed that was we brought in some folks with kind of more of a strategic defense and national security perspective. Framework usually encompasses laws and global policies, but it also deals with the operating environment, and certainly DoD writ large is a component in that. So that's some of what we're going to be talking about over the next few days and over the course of the next year. This famous quote has been used and used and used, and we use it in as many different places as an industry. We use it in as many different places as we can. But in this context, I wanted to talk about what's going to happen in the next 10 years. And depending on your source, European Space Agency has one number, the technical consultancy Bryce has another number, but whichever source you're looking at, it's between 40 and 95 missions to the moon in the next 10 years. Just let that sink in for a second. Just like absorb that, because we've only had a few missions to the moon, whether it's the Soviets, whether it's the Americans, whether it's the recent effort from China, the failed efforts from India and Israel. There haven't been that many missions to the moon, and a lot of them have wound up as multi-million-dollar craters, tens of million, $100 million craters. But in the next 10 years, there are, if you follow Bryce reports, there's 95 missions going to the moon. So if you have an environment where there are 95 missions to the moon, you also have a very, very robust low Earth orbit, geosynchronous orbit environment as well. So those 95 missions are broken up between about 11 nations. Many of those missions are partner missions, but the United States, based on the current budget and the current allocations, has about 72 missions to the moon in the next 10 years. Now, I don't know if that schedule is going to play out the way it was designed, but it is boggling to me to imagine 72 American missions going to the moon. And equally boggling if those budgets change and that mission focus changes. You have 11 nations with 23 missions that are going to the moon, whether the United States does or not. So I think this is an opportunity for us to lead in a way that we haven't for 50 years. And it's also a way to partner and have, some of that Starfleet Academy global partnerships in developing space. Or we could just step back, not commit the budget, not commit the technology, not commit the workforce, and there will be consequences to that. So I'm going to stick with the hopeful vision of the current budgets and the current mandates, and hope that is continued, because I think this is possibly the most exciting decade I've ever been alive for. I was very, very involved in the first decade of the internet rolling out, and that was an amazing time, and the world changed dramatically. To be a part of this rollout for this next decade, as much of a futurist as I am, as much of a I will say crystal ballology, the crystal ballology, I joke about that I try to look into the future and see what's going to happen. I really can't predict what happens when the world sends nearly 100 missions to the moon in 10 years. And some of those missions are already in place. We just talked about China returning a sample from the moon for the first time in 40 years. That is a remarkable achievement. So the next 10 years could change absolutely everything. In order for things to change, there are 7 fundamental technologies. I refer to them as civilization shifting technologies. Each of these each of these technologies, in some cases, have taken thousands of years, not hyperbole, thousands of years to evolve, right? We went from bone and stone era to industrial steel, Kevlar, Spectra, and Dyneema materials, right? It took us 10,000 years to go from 0 on a strength spectrum. It took us 10,000 years to go from 0 to 7. Industrial steel is about 3.5 gigapascals. Spectra, Dyneema, some of those materials, those aramid fibers are nearly 6 and 7. It took us 10,000 years to go from 0 to 7. And in the next 10 to 20 years, we could go from 7 to 70 gigapascals of strength, whether that's carbon nanotubes or graphene or some combinations of those. Materials are core to going to space. Energy is core to going to space. We have to master biotech, communications, robotics, and computing in order to go to space. There's a reason why there's been a 50-year gap between going to the moon the first time and then developing this vast cis-lunar econosphere over the last 50 years to going back to the moon now. We have to master these civilization shifting technologies in order to go to space en masse. And that's, I think, what we're all trying to accomplish. So how does this grand architecture roll out, right? It seems like most of what I just described was really preamble, but ultimately, how does this unfold? There's 6 big parts to it: launch, Earth observation, communications, in-space transport. Our component of the Lunar Elevator, I think, fits in there: space stations, mining, manufacturing, and ultimately space-based solar power. So I feel like those are kind of the big aspirational targets and projects, but I want to break it down a little bit more detailed. This whole revolution that we're talking about is only possible because of reusable rocketry. When I started on this on the NASA project a really long time ago, the idea of reusable rocketry was science fiction. And equally, the idea of a space elevator was science fiction. Fast forward, well, no, I'm not going to fast forward. Still 20 years ago, I had the choice of working on one or two of those technologies. I chose the space elevator. It wasn't easy. I felt it was the best technology for mass cargo, mass transit, off orbit, off Earth transportation. And I bet my career on the space elevator, for better or for worse. If any of y'all know my history, it's better and worse. I did not expect, and in fact, I actively scoffed at the idea of reusable rocketry. But then fast forward to about, that was in 2001, 2, and 3. Fast forward to 2004 and 5, I saw Jeff Greason bring a small rocket engine into a conference and demonstrate fast relight capabilities. And all of a sudden, the world changed just a little bit. That reusability changes everything. SpaceX, Blue Origin have obviously astounded the world with their reusability, but notably there's about 7, if I'm counting it right, there's 7 reusable rocketry companies in the United States. There's more than a dozen in development. Tom Olson is going to talk a bit about the technologies behind some of this stuff and how that technology kind of scales back to us down here on the ground. But this revolution in rocketry has made it possible to do things that were not possible 20 years ago, financially, economically, logistically, scientifically. This reusability has changed everything. And one of the fastest immediate impacts was on satellites, whether that's on communication satellites or Earth observation satellites. The CubeSat form factor evolved over that same 20 years. And what I remember an Air Force officer telling me that he referred to CubeSats as long form space debris. That is how he described it. Long form space debris, persistent space debris. That's how he described CubeSats, because when they were first coming out, they're so small, they were almost untrackable. 10 by 10 by 10 centimeters is a pretty small asset to identify and track when it's traveling, 22,000 kilometers an hour, 300, 400, 500 kilometers in the sky. So there was a lot of skepticism in the Air Force about this new form factor. Fast forward 10, 15 years, the CubeSat form factor is the de facto standard for a lot of organizations. And they can do remarkable stuff, stuff that no one expected 5, 10, 15 years ago. Even 3 years ago, there's been some breakthroughs. So launch has enabled this global fleet of space assets in mostly in LEO, but also in GEO. So that's kind of the first step in this grand architecture, is get really, really good at launch and Earth observation and communications. But launch also plays into our everyday lives. It is conceivable that within the next 5 to 10 years, many American cities could have spaceports attached to them, whether that's for, and I'm gonna lump in supersonic technology, But whether that's with supersonic technology or point-to-point suborbital, that technology and the infrastructure necessary for that technology could shrink the planet in the same way that the internet shrunk the planet 20 years ago. So launch comes in a lot of different flavors, whether we're trying to go from Seattle to Tokyo, or whether we're trying to go from an Uber to orbit, ride sharing to orbit. It changes the nature of getting to and from space. But if you do ride share to orbit, which is happening all the time, usually you get to the wrong destination, or you just accept wherever the main payload is going, and you decide you're going to go somewhere near. Now, if you're a high school and there are high schools building satellites, or if you're a college and there are a lot of colleges building satellites, then the destination is maybe not as important as the process of education that it took to build the satellite. But if you're a company, where you land or where you end up in is really important. So in-space transportation becomes more and more and more important. And that means you've got to figure out, if you're going to take a space flight launch to orbit and you're going to go to point XYZ and you really need to be at point X, ABC, how do you get from one to the other? And that means space tugs. Tuesday, we're going to speak with the vice president of Momentous, and she's going to talk about how Momentous, just a 4-year-old company, is valued at $1 billion in their upcoming SPAC IPO. It's that there is demand for that service. It is a necessary and vital technology. It's a gap actually in most of the development. And so here they are coming along with commercial technology to get you from one spot in orbit to another spot in orbit. They just recently announced that they've got some transportation pushing towards the moon. So I think that's super exciting. So once you've got launch and once you've got in-space transport, then things start getting really interesting really fast. I'm going to mostly skip talking about the Lunar Elevator because I'm going to talk about it a lot on Wednesday as we kind of end the session, focus on the moon. But a Lagrange point station attached to the Earth, and the Lagrange point station attached to the moon gives you an awful lot of capabilities in the space station sector, right? And so we're talking about space stations at low Earth orbit, geosynchronous orbit to a lesser degree, and the L points, and ultimately I'm going to lump in space stations on the ground of the moon as well. That technology is evolving very quickly. We talked quite a bit about the International Space Station, but there are many nations and a few companies working to develop space station technology. We're bringing in Dr. Rob Hoyt to talk about some of the work that they've done on the International Space Station and some of their plans and expectations. And we're also bringing in Justin Kugler to talk about Made in Space and some of their stuff. And it's important, again, to note, because we're not focusing on the hardware so much as we're also focusing on the business and the economics of this, that both of those companies were recently bought for multi-$100 million buyouts, exits, because, again, they have the backlog of clients, they have future potential, and so they're going to talk about what they're doing on orbit. Finally, we start moving into stuff that's a little bit more aspirational, manufacturing and mining, both in orbit and from the lunar surface. That's a little fuzzy. It's a little hard to say what I would say 7, 10, 12 years out looks like. But it's going to take 7 to 15 years before we're really actively mining on the surface of the moon. But it does fit within our 2020 to 2035 timeframe. So we do want to talk about what comes next. And within that context, we're going to talk about space-based solar power. Personally, that's one of the reasons why I got into space in the first place. I wanted to power 40% of the global population by powering the top 300 cities of the world with clean, green, limitless energy. And it was because of space-based solar power that I made my choice between space elevators versus reusable rocketry. Some might say I chose wrong. I think the verdict is still out on that. But ultimately, we needed heavy lift in order to build space-based solar power from the ground of Earth. However, if you've got the rocketry to build up space stations and mining capabilities on the moon, you also, by default, have the technology necessary to build space-based solar power systems from the surface of the moon. So we're going to explore that with Doctors Jaffe and Gerritsen on Wednesday. And that ultimately is the grand architecture. Certainly, I believe that our Lunar Elevator plays a role in that, but it is by no means the whole story, right? This is just one cog in a very, very complicated, large system. And I want to talk about the system, right? The node is more powerful. The network is more powerful than the node. Even if the node is NASA, even if the node is SpaceX or Space Force, even if it's Stanford or University of Washington or new programs in the field, Vanderbilt, Cal Poly, there's so many individual nodes that are enormous. Each of these nodes are enormous, but there's also tens of thousands of other additional nodes. Now, I'm an old school nerd because I liked space when I was a kid, but I also spent a lot of time in the heavy metal and going to some really amazing concerts. So I created an acronym called AC/DC in homage to one of my favorite bands. And that stands for academic, civil, defense, and commercial. And these players kind of make up the global ecosystem for the cis-lunar econosphere. And as each of these individual nodes become more individually powerful, it makes the larger network that they are a part of even more powerful. Again, I mentioned the early days of the rollout of the internet. I feel like we're at exactly that same point in time that these individual nodes are strengthening and building out capacity, but as you connect those nodes, it becomes far more resilient. So it's because of this network and it's because of the strength of these nodes that I have a lot of confidence over what the next 10 years, 15 years is going to look like. There are actually, not figuratively, actually tens of thousands of academic, civil, defense, and commercial actors in this field. And that represents hundreds of thousands of workers, hundreds of thousands of people employed in this field. And that we're not, and I'm only counting the space division of Boeing and the space division of Lockheed and the space division of Raytheon. If you start bringing that stuff in, you're talking about millions and millions of people. So the network is really, really powerful. I'm going to wrap up here in a bit with talking about how this is going to ultimately unfold. On the one side, there's the idea factory, and I refer to that as the network that we just described. There's tons of good ideas. There's a lot of bad, flawed ideas. The market will find the balance. Government policies will find some balance. Good ideas will rise, bad ideas will fall. But this idea factory makes it possible to start building public-private partnerships with governments, with academic institutions, with other corporate institutions, and ultimately create the infrastructure that we're all working towards. So what might this look like? The idea factory is going to generate revenues in a lot of different ways. It's going to use space technology as a lens for its research. It's going to pick a problem, aim for that problem, think and work towards that problem, invent something, and then it's going to license that something. And it's probably going to license it beyond the aerospace community. We're going to be talking to Baratunda Kola later this afternoon, Dr. Kola, about some of the work that he did at Georgia Tech to do exactly that. There are going to be spinoffs and exits. I've just mentioned Dr. Hoyt and Justin Kugler. And there are going to be companies that build operating subsidiaries that just work on this idea factory. A shout out to NASA and Space Force and US Space Command and our other international global partners. They will wind up being a component, in some cases lead, in some cases follower clients in these larger efforts. Certainly I want to say congratulations to NASA and the courage that they had, 6, 8, 10, 12 years ago when they committed to a course of commercialization. There were a lot of folks there that risked their careers, and I would argue that the successes of Dynetics and Leidos, the successes of Blue Origin, SpaceX, and then dozens of other smaller companies that are not as well known, not as well recognized, Relativity Space, Rocket Lab, Sierra Nevada, many companies that have worked in partnership with NASA and are now beginning to work with US Space Force. That philosophy of commercialization that was pioneered and then accelerated, that has transformed the industry, and I don't think that that's going to change. I don't think that's going to stop. That kind of symbiotic partnership is absolutely necessary. And then ultimately, what do you get from that is you get lunar outposts and cargo transport and orbital logistics, right? This is the infrastructure that we are ultimately all going to be dependent upon to build out this cis-lunar econosphere. And then more granular, what kinds of things are we going to get out of this? We're going to get strong string. We're going to get better alloys. We are certainly going to get better at communicating and computing. I recently saw an article about a pretty impressive set of chip technologies that we'll be describing later today. And the director of the Graphene Council is certainly going to be talking about materials and energy. So this idea factory is really going to be in hyper overdrive over the next 10 years to support these public-private partnerships and the infrastructure that we're developing. As for some of the things we're going to get out of the partnerships, the public-private partnerships, we're going to get space domain awareness and enhanced communications capabilities. And ultimately, the infrastructure that we're going to wind up with. Yes, I believe we're going to have a space elevator, but we're also going to have real estate on the moon, on orbit, at the Lagrange point. We're going to have fueling capabilities. We're going to have mining capabilities. Settlement in a lot of different flavors is going to be a natural outcome. And we're going to learn how to do arguably the most difficult kinds of construction. So that's what this grand architecture really looks like. I want to stress that governments around the world, mainly the United States, governments led us here, but the innovation that's happening is happening so quickly at the individual companies. Remember, I said that there's thousands of individual programs happening right now with thousands of budgets and thousands of individual missions, that the innovation spectrum is outpacing the government's goals. So we're getting more, in the same way the internet evolved, we're getting more and more ideas from more and more places. And whereas the government used to be the director and controller, they are now becoming clients, anchor clients for sure, but clients of a larger ecosystem. So these are the parts of what I believe is the grand architecture for the next 15 years. I'm happy to take questions. I know I talked for a long time about a lot of things here. This is something that's very near and dear to my heart, and I hope that it lays a powerful foundation for what we're going to be doing over the course of the next year with the foundation and with Tim's team. I want to stress my thanks to Tim and his team for orchestrating this event series. We wouldn't be having this conversation. We wouldn't be thinking about the future in the way that we are without them. So thanks very much to the Foundation for the Future, their sponsors, and certainly their combined leadership of the president and their directors. With that, I'm going to open this up to comments, questions. I'm going to stop sharing my screen. And I want to, I'm interested to hear what you have to say. Thanks very much.
Hi, Michael. This is Michael Mealing. Had my hand raised, but
Thank you.
didn't know if you saw that. So I'm just going ahead and jump in with a quick question. In I think the last slide, you had government is anchor client. From an investment standpoint, and this is something that you and I have talked about, and even something that Tim and I talked about last week. How do we get to, because right now it's not just NASA, well, the government, NASA DoD as anchor client, it's NASA government as only client. There are a few of the CLIPS companies that have some very small commercial applications that are right along, but we are suffering from a lack of demand generation beyond the government. And everything that you've been talking about this morning is really on the supply side. Do you have any thoughts, or does anyone else at the event have any thoughts on how do we ensure Congress that government is not going to be the only client for the foreseeable future? Because that is one of the number one comments I've gotten from congressional staffers and members is how do we transition to government being a client and not the client?
I really wish I had an actual answer. I'm going to do a little bit of hand waving here because you're absolutely right, Michael, that a client base of one does not make a market. I think that's actually your quote. I think you've said that to me before, and so I'm just parroting back what you said to me. But it's true. It's accurate. A client of one does not make a market. I would say that I don't think it's a client of one for very much longer. We are in that precarious point of, if you build it, maybe they will come. And I say that because, you have companies like Relativity Space raises $500 million to build a new rocket system. What justifies that? And I think that is justified by the potential of new markets opening up, not certainty, but the potential of new markets opening up. And when you look at kind of the global experience of space, and I know you know, but I'm saying this for the rest of the public listening, I'm the president of the International Space University's U.S. Alumni Association. So I do have my fingers in the pulse, on the pulse of kind of the global space experience. I would say that there is a developing ecosystem for space commercialization. We're not there yet. There is a market of one right now. Well, I would say there's a market of two. I would give Space Force its own market and NASA its own market, because I'm not talking exclusively about the moon. You and I spend most of our time talking about the moon, but I think we're talking beyond that. I think there's a smaller market for space stations, an enormous market for satellite communications and satellite observation. So if you only limit it to the moon, which is what you and I talk about, yes, I think you're right. There's a market of two, one or two. But I think that there is a soon to be larger market of other nations, and that AC/DC community that I just referred to, I think is going to help spur that market. But it's unproven. It's absolutely unproven right now.
And I would have to agree. I mean, as a VC fund focused on this sector, LEO commercialization, it's a challenge, but there's a path, and we sort of understand the path. The conclusion, I wouldn't say conclusion is too strong of a word, that I and others in the investment community are looking at is, if you're talking about beyond LEO, then the only thing that really justifies the investment across the board is humans. Nothing else really needs the level of infrastructure that we are talking about, because it's very hard to make any of those investments close unless there are self-floating carbon units willing to go spend large amounts of money to leave LEO. So, thank you.
I will confess my optimism that the reason for doing all of this stuff is for those humans to get out there. So I'm okay with kind of front loading the market a little bit, but you're right. Like, it's a legitimate question, and I think you are looking at it from the appropriate perspective of a financier in the space community. You're looking at it from the perspective of today, right now. And I am looking at, what does the next 15 years look like?
Oh, absolutely. Well, anyone that's in venture capital actually is always looking forward 10 years, because that's when you expect to sell your companies. You do your investments now based on what things look like then.
Right.
But this is not just the finance perspective. This is also Congress's perspective. Like I said, every time we talk to congressional staffers about anything beyond LEO, the number one question is, how do I not become yet another $12 billion government program that's full of just rent seekers looking to suck money out of the taxpayer?
Right. Good questions.